Welcome to part 2 video of Chapter A, Section 3. So the previous video we did some AND problems. These are OR problems, number 3 and number 4. And check out over here in the box, a very important detail. And that's the thing with math. The difference between doing well and not doing well is often the details. So we are supposed to switch the signs anytime we divide by negatives. So obviously that's going to be coming up here. Otherwise we wouldn't have warned you. So the advantage with an OR problem is you can see the two problems you got to solve. So not any more difficult than normal, just a little bit more work to do. Well, how do we move the 5j over? So I could subtract this 5j over, and I would have 3j less than negative 21. Now again, I know that there is a negative in the problem, but are we dividing by negative 3 or are we dividing by positive 3 to get rid of that? We're dividing by positive 3. So if I'm dividing by positive 3, I'm not switching the inequality sign around. J is less than 7, one answer. All right, this other guy, got to get rid of the 31 first. I got to subtract 31 from both sides. And now, how do I get rid of the negative 9? I got to divide. And if I'm about to divide by a negative, that means that guy gets flipped around. So divide by negative 9, we get positive 3. And speaking of flipping around, I'm telling you, you're going to want to do this. I am going to literally flip that answer around. So these two guys mean the same thing. So the little end is still facing the 3. The little end is still facing the 3. But when you go to shade, you know that that guy's going to be shaded to the right. All right, and let's go ahead and do this one first for no particular reason. So I got a negative 7, and I got a positive 3. So I'm going to do the 3 first. Close circle, greater than, shade to the right. The other one, this guy. J is less than negative 7, no equal sign, open circle, shade to the left. So if this was an AND is be no solution. They don't overlap anywhere, but it's not an AND, it's an OR. And all we do for ORs, let's get a new color, is to just transfer what you've already drawn onto the drawing. You know, I understand that maybe doing the above and below thing wouldn't really be necessary for these, but when you do an AND problem, it's extremely helpful. So my advice to you is just to be consistent and go ahead and do the above and below thing. So again, it's, an OR, one or the other. So this guy, yeah, he counts, or this other guy counts as well. So as far as interval notation, now this is a little funky because there's 2 sections to the graph to describe. I'm going to write this below the solution set blank because I don't really have room. So if I said, hey, where's this shade? You would probably say it goes to the left forever, which we can represent negative infinity, comma, it stops at negative 7. Always put a parenthesis for the infinity signs, open circles, get brackets. Now, how about this other section? If I said, hey, where does that go from? You would probably say it starts at 3. So I'm going to go bracket, because it's a filled-in circle. And you would probably say it goes on forever to the right. It's positive infinity. So here's the new part. There were actually 2 parts to that shade. So a big old U, that stands for union. So it's a union of 2 answers. So it's this guy or that guy, or a union of the 2. All right, moving on. Let's try number 4. So again, all we want to do is solve like normal. Put a little line down the middle to separate these guys. I see a positive 6. I'm going to subtract him to the other side. Okay, and a little trick here, right? If we have negative x, we don't want negative x, we want positive x. So if I switch the sign on the left, I would hope it makes sense you switch the sign on the right, but really, we just divided by a negative to do it. So if you're going to switch the negative on the left and you're going to switch the negative on the right, I hope it would make sense that you switch the inequality in the middle. The guy over here, again, don't let the fraction scare you. Big old fraction bar means divide. Well, how do we get rid of a divide by negative 3? We times it by negative 3. But if you divide both sides by negative, you got to switch the inequality around. If you multiply by a negative, you got to switch the inequality around. So that one's easy to forget. How do I get the minus 15 to the other side? I add it, and I would have a 12. Whoa, there's one answer. I'm going to go ahead and do him first. So x is less than 12. Open circle, less than goes that way. This one is also an open circle. Greater than, shade that away. So this is where I think the above and below thing really helps out. Because if you are going to transfer the two lines on there, in other words, or one or the other counts. This one counts. I'm going to just transfer him down right onto the answer line. The bottom one counts as well. I could just transfer him right up. I got him. So now coincidentally, what happened? The entire number line got shaded in. So you could write all real numbers. This is abbreviation for real numbers if you didn't know. So all real numbers is acceptable answer. Or I'm going to go interval notation, which is to say, where's the shade start on the left? Well, it goes forever to the left, comma. Where's the shade go on the right? It goes forever on the right. There we go. So that's interval notation. So everything's an answer to that. No matter what number you plug into that problem, it's going to work. All right, moving on. Word problem number 1. There's 2 word problems. So let's sneak this one in here, and then maybe we'll wrap things up. So the exterior angle inequality theorem. Remember anything from geometry? States that an exterior angle, and that would be this guy right here, exterior angle measure is greater than the measure of either of its corresponding remote interior angles. So remote interior means the ones that aren't touching, the ones that are away from it. So that's those 2 guys. So basically what we're saying is angle 4 is greater than those other 2 angles added up. So angle 1 plus angle 2. So let's see. Write 2 inequalities to express the relationship among the measures. So we just did that. So angle 4 is bigger than angle 1 plus angle 2. So 2, could you flip that around? Yeah, that's basically what we're saying. So let's use variables instead this time just for the heck of it. Let's say that this is x. Let's say that guy's y. And let's say that guy is z. So we would be saying if you added x and y together, they're going to end up being smaller than that outside angle, or z. All right, so just a little geometry to throw at you there. All right, we're going to get these 2 above and below graphs in here real quick here. So for this first one in this box, you can probably say to yourself, well, how's this a compound inequality? And here's how it becomes a compound inequality. So give me some numbers that are smaller than 3. Well, let's see. That would be from 3 going this way. Right? Well, absolute value there, right? So let's test a number. What is the absolute value of -3? It's positive 3. So is positive 3 still less than or equal to 3? It is. But if I go with -4, and I plug -4 into that problem, the absolute value of -4 is 4. Is 4 less than 3? No. So in other words, I don't end up with answers down here anywhere. All my answers end up being between these 2 guys. And if you remember, the shades that end up being between like that was an and. So really what we're saying is the numbers have to be bigger than -3, and the numbers need to be smaller than +3. So that's going to be important here in a couple minutes coming up. So the other guy here, number's bigger than 2. Okay, open circle this time, right? Number's bigger than 2 is this, obviously. All right, well, give me some negative numbers we could pop in and make that true. What happens if I put -3 in there? Absolute value -3 is +3. Is 3 bigger than 2? Yeah. So all the negative numbers that are smaller than that guy work as well. So that one becomes an or because they're shaded both ways. So x is less than -2 or x is greater than 2. Okay, so that's just a little preview of that. So coming up here in the next video, we'll talk about how to tackle the actual problems. Thanks for watching.